Alright, well, I'm going to do the Chapter 1 review this morning. It's actually the second time I'm doing this review, which is really not exciting to me. I recorded it once, and there were just a few things that I really wasn't happy with, so I'm doing it again. Took about an hour and a half the first time that I did it, and I imagine it'll take close to that now. So make sure you've got a decent block of time to do this thing. And I always write my reviews to be just like the tests. So when you go to take your test, there won't be any problem that isn't just like a review problem. In fact, when I write a test, I usually open up my review, and then I take the questions and I'll delete some of the questions because I won't ask as many questions on the test as I have on the review. And then after I delete the questions that I don't want to ask on the test, I scramble the numbers up. So if question 1 was one of the numbers I want, one of the types of questions I would ask on the test, I would probably renumber this, and instead of having 2 parts to this question that asks write a word description, I'd probably only have 1, and it won't be number 1 on the test, maybe it'll be number 17 on the test. But the instructions on the review and the instructions on the test will be the same. So there'll likely be a problem on your test that says write a word description of each set, and it gives you, you know, a set. Probably not. It probably won't be a 2-part problem. It'll probably be 1 part, and it won't be number 1. It'll be some other number. My best guess is that the test will have about 25 questions worth 4 points each. That's kind of the standard length of a test that I like to make. It could be a little bit longer if there's a lot of short problems. I know on this review there's like 38 problems, and so but plan on about 25 problems, 4 points each, and have exactly the same instructions, at least as close as I can make to the same instructions. For the word problems, the words have to be just different, but for most of the problems, you know, find the cardinal number of the following sets, those instructions will be exactly the same. Alright, so I know this video's long-ish, and the last 2 problems on the review are the word problems, and I didn't want you to skip over those, so I'm going to do those first while you're, you know, theoretically fresh. So I'll do problems 37 and 38, which are the word problems, and then I'll come back to problem 1. It's always kind of my hope that before you watch the video of me doing the review, that you've made an attempt at the review yourself. So you shouldn't watch this unless you've actually tried the review and checked your work. And you probably don't have to watch me do every single problem. You should probably kind of fast forward to the problems that you just didn't know how to do, just to kind of speed up the process. So first word problem, which is the second to last problem on the review. A company's considering manufacturing a new flavor of yogurt. They're considering regular yogurt and mint yogurt. And then look at this. I don't see regular and mint here. Let me change this to, they're considering, I don't know which one to change it to. Now I do know. I'm going to try to be consistent with my answers. Haha. On my answers I say lemon and cinnamon. So they're considering lemon and cinnamon. My best guess is I took a problem from the section 1.7 and I changed it just a little bit to make it to make it a review question, and I just didn't change it perfectly. So, companies considering manufacturing a new flavor of yogurt. They're considering 2 flavors, lemon and cinnamon. 100 people were asked, and here's what they liked. So I'm going to make up my Venn diagrams, and I'm going to make one of the sets in the Venn diagram, or one of the circles, for the lemon, and another one for the cinnamon. And you could write L and C rather than writing the whole words. So now to fill in my Venn diagram, I always fill in the overlapping regions first. And the overlapping region is going to be the number of people that liked both types. So in the overlapping region, I'm going to put a 40. And then the rest of the numbers, the next 3 numbers that I see in the problem, this 60, this 70, and that 100, you have to subtract something before putting those numbers in. So to fill out the lemon circle, I'm going to take the number that's associated with the lemon, 70, subtract the 40 that liked both yogurts, and that will give me 30 to fill in the rest of the lemon circle. So this separates the 70 people that liked lemon 40 people like both cinnamon and lemon, and 30 just liked the lemon and they didn't like the cinnamon. So done with that, done with that. Move on to the 60 that like the cinnamon. Of the 60 that like the cinnamon, 40 of them also like the lemon, and 60 minus 40 is going to give me 20 for the rest of the cinnamon circle. Again, that breaks up the 60 people that like cinnamon into 40 that like both and 20 that just like cinnamon. And the number that goes outside the region comes from this 100. I'll take that 100, and every number needs a number subtracted, and the number that needs to be subtracted from the 100 is 30 plus 40 is 70 plus 20 is 90. So outside the circle, somewhere in the open rectangle part of the Venn diagram, I'm going to get the number 10, which represents the 10 people that didn't like either of the flavors. I'm just going to copy this over here, because when I go to answer my word problem questions, it's easier to have the graph staring at me rather than having to flick back and forth. All right, now I'm going to answer the questions that are related to this diagram. So how many liked only lemon? That's going to be this region right here. Those 30 in the lemon circle liked lemon, but they didn't like cinnamon. How many liked only cinnamon? That would be those 20 in the cinnamon circle, but outside the lemon circle. And how many liked exactly one of the two? The 30 that liked lemon but didn't like cinnamon liked exactly one of the two, and the 20 that liked cinnamon that didn't like lemon liked exactly one of the two. So the answer to part D is going to be 50. So of the word problems, that's the easier of the two word problems. And I don't know that you're going to get two word problems on your test, but it's likely that you will. The second word problem talks about, it says 150 students were asked which of these restaurants they've been to this year, and some have been to Olive Garden, some have been to Oregano, some have been to Outback, and some probably haven't been to any of the three. And the first thing I'm asked to do is make a Venn diagram. I should be consistent with my answer. There's answers for every problem, and I am being consistent with my answer. I see Olive Garden, Oreganos, and Outback. Consistent in where I put the circle, where I name the circles, just so if you're checking your work to my work, I'm consistent with myself. But if you've done this problem ahead of me, and you know your Outback and your Oreganos positions are different, it doesn't matter. All right, so I always try to group these problems into triples, doubles, and singles, and I put them in the order that you need to solve. You need to fill the diagrams on. Again, only one number goes in unchanged. The number that goes in unchanged is the one that's been to every one of the restaurants, and that's the 5 that goes dead center in my diagram. And now I'm going to start working with the 2 of a kinds. And again, every time I put a number in the diagram other than the dead center number, I have to subtract first. And I subtract anything that's in that circle already, and the 5 is in all of the circles. So for the next thing I'm going to put in the overlapping region between Olive Garden and Oregano's, and that's this little region here, that little right above that 5. I'm going to take the 10 that have been to both, subtract out the 5 that have been to all 3, and I'm going to get 5 for the rest of the overlapping region between the Olive Garden and the Oregano circle. And what that tells me, that of the 10 people that have been to Olive Garden and Oregano's, 5 have been to all 3, and 5 of them have been to just Olive Garden and Oregano's, and they weren't to Outback. The next double number I see, because it's Olive Garden and Outback, 2 places, will go right here between the Olive Garden and the Outback circle. And that 15 that's given, I need to subtract the 5 that's already placed in that overlapping region, and that will give me 10. to go in that portion of the diagram. And what that does, it splits the 15 people that have been to both Olive Garden and Outback into 10 that have only been to Olive Garden and Outback and 5 that have been to all three. And then the last one, I'm going to take this 20 that have been to Oregano's and Outback. It's going to go in here because it's the overlapping region between Oregano's and Outback that I haven't filled in yet, minus the 5 that have been to all three, and that's going to give me a 15 that have been to Olive Garden, Oregano's and Outback that haven't been to Olive Garden. Done with the 3 of a kind, done with the 2 of a kinds. Now I move on to the 1 of a kinds. So for the rest of the Olive Garden circle, I look at the numbers that are already in the Olive Garden circle. The numbers that are already in the Olive Garden circle are a 10 and 2 5s. Those add up to 20. And I'm going to take the 50 that have been to Olive Garden. I've already placed 20 of them, and I'm going to replace the rest of them by taking that 50 minus the 20 that's already in the Olive Garden circle, and that's going to give me a 30. And so there's going to be 30, it says 30, students or people that were surveyed that have been to Olive Garden, but they hadn't been to Oregano and they hadn't been to Outback. So all 50 that have been to Olive Garden have been categorized. Now I'm going to move on to the Oregano's. Done with that number, work with this Oregano's number. So in the Oregano's circles, the numbers that are in there already are a 5 that have been here, 5, 5, and 15. So in the Oregano's circle so far there's 25. I'm going to subtract that 25 from the 45 that have been to Oregano's, and that's going to give me the number that goes in the part of the Oregano circle that I haven't filled in yet. And that tells you how all 45 people that have been Oregano's, where they've been to. 20 only to Oregano's, 20 only to Olive Garden and Oregano's, 5 to all three, 5 to Olive Garden and Oregano's, 5 to all three, 15 to Oregano's and Outback. Now I look at the Outback circle. In the Outback circle, the numbers that are there are 10, 5, and 15. I'm going to add the numbers that are in the Outback circle already and subtract them from the total. So 10 plus 5 plus 15 is, what, 30? And I'm going to take the 40 that have been to Outback minus the 30 that have already been placed in the Outback circle and get a 10 for the rest of the Outback circle. Done with that, those numbers. The only number that I haven't dealt with so far is the 150 total students, and that number I need to subtract, and what I need to subtract is any number that's in my diagram already. So I'm going to start adding the numbers in the diagram. 30 plus 5 plus 20 plus 10 plus 5 plus 15 plus 10. So 50, 60, 70, 80. I think it comes out to 95. You can add that in your calculator if you can't add it in your head. And when you subtract, I'm going to get 55 for the number that goes outside the circles but inside the rectangle, and that's the 55 people that of the 150 that were surveyed that hadn't been to any of the 3 restaurants. So once I get my Venn diagram filled in, it's supposed to be easy-ish to answer the questions. So now I'm going to answer the questions. I transferred the Venn diagram to the sheet that has the questions on it, so it just makes it easier for me to point. So first question, how many did not go to any of the 3? That's the 55 that are outside the circles. C, the or questions are the hardest questions because the or sometimes counts more than you want. And question C is going to count any number that's in the Olive Garden circle or the Oregano circles or both. So question C is going to count all these numbers in the Olive Garden circle and all these numbers in the Oregano circle. So I'm going to count this 30, this 5, that 20, that 10, that 5, and that 15. Because that's all anybody that I've highlighted there in what I guess is green has been to one or the other. And it doesn't make any stipulations on whether they've been to 1 or 2 of them or if they've been to Outback or not. So I'm just going to add all those numbers up. 20, 30, 50, 80. I think it comes out to 85. Um, all right, so I'm going to pull out a different color to do part D. For part D, I'm looking for the ones that have been to Outback or Oregano's, but not to Olive Garden. So what I'm going to count, I'm going to try to border the region in pink, maybe shade it in pink even. So these 10 people right here, they've been to Outback, so that counts to being Outback or Oregano, and they haven't been to Olive Garden, so I'm going to count them. I'm going to count those 15 people because they've been to both Oregano's and Outback, so that counts as being Outback or Oregano's, and they hadn't been to Olive Garden. And I'm going to count these 20 people because they've been to Oregano's and they haven't been to Olive Garden. Those three that I highlight in pink all fit the criteria that they've been to Outback or Oregano's. Some of them have been to one of the two, some of them have been to both, but none of the ones that I highlighted in pink had been to Olive Garden, and that's what it needs for part D. So my answer to this is going to be 20, 30, 45. So when you get your test word problems, how I'm solving the word problems now, it was kind of what I want you to do in terms of showing if there's numbers that needed to be added, what numbers have to be added. If you want to highlight on your graph in color, that's nice too, but that's not as important. And then the last one, how many have been exactly 2 of the 3? So that's going to be an overlapping region. These 5 here have been to Olive Garden and Oregano's, but not Outback, so they've been to exactly 2 of the 3. These 10 here have been to Olive Garden and Outback, but not Oregano's, so they've been to exactly 2 of the 3. And these 15 have been to Oregano's and Outback, and they haven't been to Olive Garden, so they've been to exactly 2 of the 3. And the answer for part E is going to be 30. All right, so there's the word problems for our test. So hopefully you don't feel too intimidated by the word problems. There's going to at least be 1 on the test, very likely 2. They all solve the same way. You just go from the inside out, you subtract the rest of the way, and then you answer the questions that are posed. All right, so now back to the beginning. I think this is actually section 1.2 more so than 1.1, but eventually we'll get some problems from 1.1. So the first questions, 1 and 2, want me to write word descriptions. In word descriptions, there's a lot of flexibility. When I attempt to write a word description, I look at the set, and most of our sets only contain natural numbers. And so when I do problem 1 and 2, because the numbers in the sets there's no fractions and there's no decimals, because the numbers are natural numbers, I need to include the word are natural numbers in my word description. Otherwise, my answer probably won't be right because my answer will allow fractions or decimals. So I'm going to say for one answer for problem 1, D is the set of natural numbers and when there's a beginning but not an ending number, I'm probably only going to use the beginning number in my answer. When I do problem 2, I'm probably going to use both the beginning and the ending number in my word description. But here, it makes sense to just include the beginning number because there is no ending number. And how do I describe this set? Well, the numbers that are 4 or larger, I probably should have a 6 in here, because I say 3 numbers establishes a pattern and 2 not so much. But anyways, these are numbers that are bigger than 4 and they include the 4. So for the word bigger, I'm going to include greater than. Or equal to. I think that's probably the most natural answer. It's correct and it's not cutesy, I guess. An okay answer, because it's correct, that is maybe not as nice because it's being more subtle. We could have said D is the set of natural numbers. If I don't include that in my answer, then I'm not going to, then I'm allowing decimals and fractions. But another way to say this, I'm kind of stuck with the greater than because the numbers are bigger than something. But had I just said greater than 3, that would be correct. Because if you look at the set of natural numbers, if you only count the natural numbers greater than 3, then you're not going to count the 3, and you're going to count the ones that we're asking for. There's got to be a third and a fourth way to describe these in using a word description, but I can't think of one right now that's better than the first one, other than the second one, which really isn't better. When I do question 2, I'm also going to use the word natural numbers, because in that set there are only natural numbers. And if I forget this part, that allows decimals and fractions into my answers, and that's not good. Usually when there's a beginning and an ending number, in my word description I use the word between, and I put the beginning and ending number in my answer. Between mathematically needs more than just the numbers, because there are words that we can write to make it so the beginning and the last number that I listed are included or aren't included. Because I want these numbers to be included, I need to put the word inclusive. And this is probably the best answer for question 2, because it only uses the numbers in the problem, so I didn't have to be especially creative to figure out what those numbers are, and it describes the set perfectly. I'll put an OK answer on. Again, the natural numbers here, that we're kind of focusing on are the numbers between 3 and 7. If I did this, if in my answer I said between 2 and 8 and put exclusive, it's going to be a correct answer because it's going to imply the same set. So if I would have tried to make cute and said A is a set of natural numbers between, and now if I expand this, 2 and 8, and then put exclusive after the numbers, it's going to count the same set, because between 2 and 8 exclusive doesn't count the 2 and it doesn't count the 8. It counts the natural numbers between 2 and 8, not counting the 2 and 8, which is 3, 4, 5, 6, and 7. Again, it's probably much better just to say the inclusive one. Okay, set builder notation. So for 3, 4, and 5, I think the sets that we're given all only have natural numbers. So when I write my answer in set builder notation, I'm going to write B equals the set of all x such that. Probably in any variation of the correct answer for number 3, you're probably going to put this, because set builder notation, you have the set braces, a letter, and then a vertical bar that we read as such that, or with the property that, and usually before the vertical bar you put an X. After the vertical bar, I need to put something that describes the set that's given in the problem, and again, the numbers in the problems are natural numbers. So I could say X is a natural number and then I'm not going to write the words, because otherwise that's a word description. Even this is getting a little too wordy. In a second I'll write something that's better than this, but this is probably a natural thing to do. And so when the range of numbers is bounded, when there's a beginning and an ending number, usually you put that beginning and ending number in your answer with an X between the beginning and ending number and less than symbols between the X's and the number, or the X and the numbers. And because you want to include the numbers, the less than symbol gets an or equal to. So this would be a perfectly good answer. This says I want the natural numbers between 2 and 5, including the 2 and including the 5. The or equal to includes the beginning and the ending number. So this is probably okay, and this is what I'd probably expect most students to get. But something that's equivalently good and probably a bit better, maybe even best, is to the right of the vertical bar, instead of writing the words x as a natural number, write the symbol for x as a natural number, which is just x as an element of n. So these are interchangeable. They mean the same thing. And then a comma, and a comma is used for the word n, and then probably 2 is less than or equal to x, which is less than or equal to 5. That's probably the best answer. You can get cute with this part by not including the numbers that are in the problem. So something you could do is you could expand, go from 1 to 6. This is kind of like an inclusive. When you use an or equal to, it includes the first and the last number mentioned. If I did something like this is like an exclusive. This is like between 1 and 6 exclusive, meaning I don't include the 1, I don't include the 6, but I include the numbers. That's a less than sign without an or equal to. But I include the numbers between, but not the first and the last number. And there's a lot of variations of this that are fine, but I can't imagine any reason to give an answer other than the top 2 answers. There's no reason to bring numbers into the problem that aren't already in the problem. So for 4, P is a set of natural numbers between 2 and 7 exclusive. Set builder notation, so P equals the set of all x such that natural numbers, so I can either write the words x as a natural number here, or I can write the symbol. So again, your choice for there, you can write x is a natural number, and then for the comma, write an and then there's hardly a reason when you have a bounded range of numbers to do anything but to put x between those numbers, and because I want x to include those numbers, put less than or equal to signs between the number and the x's. And that's perfect. Again, there's other things you can do. You can, instead of having the symbol for x as an element of a natural natural numbers, you could write the words. So the comma, you can write the and then for this, you could probably go 1 is less than x is less than 8. That would be okay as well to interchange for that, because that means I'm not including the 1, I'm not including the 8, I'm including the natural numbers between 1 and 8, not counting the 1 and the 8. But this is probably the best, unless you just don't like using that notation and you fill up that notation with that. 5, between 2 and 7 exclusive. Now that means I don't want to include the 2 and the 7. That just means I don't put an or equal to on the inequalities. So the beginning of my set builder notation is going to be the same. Set of all x such that, and then if you want to, the shorthand notation for x as a natural number is better than the words because it's quicker to write, but I'll write the words. So again, for this, you probably could write x as an element of natural numbers, comma, and when x is exclusive and it doesn't count the endpoints, then the best way to write the answer is to put x between the given numbers. There's no need to bring numbers into the problem that aren't already there. I just don't put an or equal to. So exclusive, you get just less than's but not or equal to's. Inclusive, you get less than or equal to's if you're using the numbers in the problem. For this one, the other way to do it, because if natural numbers between 2 and 7 exclusive are the numbers 3, 4, 5, and 6. For here, you could have wrote 3 is less than or equal to x is less than or equal to 6, because that's the numbers that are defined by this. It's 3, 4, 5, and 6, and putting or equal to's includes the numbers. But I think this is just perfect for an answer, unless you like to write the shorthand notation better, or a comma better than and. Okay, roster form is much nicer. There's no flexibility in roster form other than you can change the order. Like if the numbers are supposed to be 1, 2, 3, you could write 3, 2, 1, or you could write 2, 1, 3. But there's not much flexibility in roster notation. So how do I write roster notation? Well, let me figure out what the numbers are first. So the numbers of natural numbers between 2 and 5, those are the natural numbers between 2 and 5. Inclusive means I need to include the 2 and the 5. So that's going to be the set that I need. These are the numbers described by the set in number 6. So I'm going to write the set name A, an equal sign, and then I'm going to put the elements that are described by the set in set braces, and that's all set roster form is. And again, the best you can do different than that is you might write something like A is the set 5, 4, 3, 2, but there's hardly a reason to write them in a odd order, but you can if you want to be odd. 7 is a set of odd natural numbers greater than or equal to 8. So let me figure out what that set is first. Natural numbers greater, so the natural numbers greater than or equal to 8 would be this list, but this only wants odd natural numbers. So from that list of the natural numbers that are greater than or equal to 8, I need to throw out the even numbers because it's only counting odd natural numbers. So first I listed all the natural numbers greater than or equal to 8. I got rid of the even ones, that left me with the odd ones. This isn't unbounded. I can't have a first and the last number because the natural numbers go on forever. So I'm going to have a dot, dot, dot in my answer. So I'm going to write A equals, and then the first number in the list, even though the problem refers an 8, it's not in the set. Might look something like that. 9 is the first number, 11 is the second number, 13 is the third number, then it goes 15, 17, 19, and I think I should add 14 there, but anyways, I need a dot, dot, dot. Those are, again, ellipses in my answer to say the pattern continues. And generally, I want at least 3 numbers to establish a pattern. 2 kind of establishes a pattern. I'd live with it, but I prefer 3. For 8, when I go to write my answer, I have to figure out what elements are in the set described by number 8. And to do that, I have to solve the equation that's given. The equation that's given is x minus 3 equal to 6. And to solve the equation that's given, you take what's to the right of that vertical bar and solve it. And the set that's described by the problem in B, or the set B in problem 8, just has the number 9 in it, because 9 is the only solution to the equation to the right of that vertical bar. D says I need natural numbers. So I look at the set that's defined, and it has the letter M between the numbers 1 and 4, and it tells me there's natural numbers. So those are the natural numbers between 1 and 4. I have to figure out if that is the answer or if I need to get rid of one of those numbers. And in this particular problem, when I go to write my answer, I'm going to include the 1 because the inequality that's attached between the M and the 1 has an or equal to, but I'm going to exclude the 4 because the inequality that's between the M and the 4 doesn't have an or equal to, so that means I'm excluding the 4 and including the 1. So the numbers that are described in this set are just the numbers 1, 2, and 3. I'm kind of glad I'm redoing this lecture. I sense that it's better than the one that I did yesterday morning. Hopefully it's okay. The lecture I gave over the review yesterday that I'm re-recording because I had some just dumb things that I said in it, was not my best lecture. For that matter, I think some of my lectures have been pretty good this semester, some of them haven't, and if I get the ambition, I'll re-record the ones that I wasn't that excited about. 10 through 12, find the cardinal number parentheses n of the following sets. That is, find the number of elements in each set. To do this problem, I need to list the elements of the set and then just count up how many there are. And the answer is just going to be the number of elements that are in the set. So set B in number 10 is a set of natural numbers between 5 and 10, but it's exclusive, so it's not including the 5 and the 10. So set B in this problem, it's the natural numbers between 5 and 10, not including the 5, not including the 10. So these are the elements of set B. I don't need to write these elements in a nice roster form. I just needed to know what the elements are so I could answer the question. And one way to answer the question is just to write the number 4. This would be an acceptable answer, probably the worst answer, but that you get full credit for. A better answer would be something that tells me what that 4 represents. And it's not even worded that well. I probably could have said 4 is the number of elements in set B rather than the number of elements in set B is 4. This is probably the worst full credit answer. This is probably the middle full credit answer, and this is going to be the best. Best is a nice shorthand. An N meaning the number of elements, or meaning the cardinal number, and then a parentheses followed by the set name, and then an equal sign with the number of elements in the set. That's the best answer, because I read that as the number of elements in set B is 4. Okay, so set A is a set of natural numbers less than or equal to 7. So if I start writing down natural numbers that are less than or equal to 7, I get those. I know I'm including all the natural numbers less than 7. I'm also including the 7 because of the or equal to. So those are the elements of set A. A has 7 elements. So again, the worst answer that could get you full credit would just be to say 7. And then you could say something that's maybe worded a little bit better than I did last time. The set A has 7 elements would be correct, but way more words than I need to. And then the best answer that would give you full credit, N for the number of elements, capital A because that's the name of the set, and that also says that A has 7 elements. But I'd live with any of them. Like I said, you can pick and choose with what you feel most comfortable with. 12, find the number of elements in set C, where C has 1, 2, 3, 4, 5, 6, 7. C has 7 elements. So again, worst answer, just writing the number 7. Better, but not the best. C has 7 elements. And best, the number of elements in set C is 7. The very predictable result to this question, if I'm grading your test in this question and you took the time to write the best answer, I would be surprised if you didn't get an A on the test, probably surprised if you didn't get an A on the class. And if you took the lazy way out and you wrote a 7, I'll be equivalently surprised if you get an A on the test and equivalently surprised if you get an A in the class, because this class, there's just a lot of fine detail in this class, and the more you can just kind of get used to giving me the detail that you need, the better that you're going to do in the class. Not necessarily the better that you understand the material, but at least the more careful you're going to be, and the students that don't wind up getting A's in the class that actually try, they're just maybe just a little bit careless, and they're not paying as close to attention and to the detail that comes out in this class that they need to. So strive for, when I say the best answer, strive for nailing that best answer. It's not going to hurt you. Okay, 13 through 15. Equal, equivalent, are neither. Equal. Two sets are equal if they have exactly the same elements. The order's not important, but they have to have exactly the same elements. Equivalent is different than equal. What? They just have not exactly the same elements, the same number of elements. They don't have to be the same number elements, but they can be. So the elements can be the same. Or they can be different to be equivalent. All right, so it's every semester, or maybe even every week, something a student said to me, like in the 90s, maybe like in 1996, comes up all the flippin' time in my mind, and I always share it, and I don't know why I always share it, but anyways, you'll see how I wrote here. I wrote a different E for equal and equivalent. I wrote a capital A and I wrote a small a. I don't know. I'm inconsistent. I'm consistently inconsistent how I write. And here's a capital A. There's a small a. And I had a student, like I said, I think 96 might have been the year, but in the mid-90s, come up to me one day after class, and this was before I got married and divorced, and this had to do with how I write my twos. Sometimes I write my twos like this, sometimes I write them like that, and she goes to me, "You can't even commit to how you write the number 2. How are you ever going to commit to somebody?" And it sticks with me all the time. It's like it never ever left my mind, and it just, when I wrote that, it popped into my head, and it's amazing how something, that insignificant, maybe it's significant to me, that it always comes back. So I don't know. So sorry about that, but it always comes in my mind. So for here, my answer is just going to say, I'm going to use the word equal in my answer, equivalent, or I'm going to say neither. These both sets have 4 elements. If they have the same number of elements, they're equivalent. So that's definitely going to be a word that I put in my answer. Neither won't belong in my answer, because if I pick either equal or equivalent, then I'm not going to say they're neither. And these sets aren't equal, because to be equal, both sets would have to have either the numbers 1, 2, 3, and 4. Both sets would have A, B, C, and D. And they don't have exactly the same elements, so they're not equal. 14, these sets are equal because they both have A, B, and C. So equal means they have not only the same number of elements, but exactly the same elements. But they're also, if you just stopped writing equal, that's not enough, because they also are equivalent, because equal has exactly the same elements, which those have. Equivalent, you have the same number of elements. They can be equal, the same elements, but they don't have to be. So this is actually both equal and equivalent, because they're equal because they have the same number, same elements, A, B, and C. They're equivalent because they both have 3 elements. And 15, they're clearly not equal because one has numbers, the other has letters. They don't have the same elements. And A has 4 elements, B has 5 elements. They're not equivalent because they don't have the same number of elements. So this gives me a neither. They're not equal because they don't have exactly the same elements. They're not equivalent. They don't have the same number of elements. So they're neither. All right. Is A a subset of B? And this subset definition is only the 2-level one. This one's okay if they're equal, but the only thing you have to check is A a set, and is A contained in B? So I'm going to do my checks for this one. Is A a subset of B given A is the letter A and B is the set A, B, and C? So test 1, is A a set? And the answer is no, because there's no set braces. For A to be a set, it would have had to have been written like that. So A is not a set, so A can't be a subset of B, because to be a subset of B, you have to be a set. So my answer here is going to be false, because A is not a set, because the instructions say if it's false, give a reason, and the reason it's not a set. Now I look at the same question. Is A a subset of B, given that A is the set that contains Phoenix, and B is the set that contains Phoenix, Los Angeles, and San Diego? Well, test 1, is A set? That answer is yes, because it's in set builder notation. So that's the first of the 2 checks I have to do for a subset. And then, is A contained in B, meaning every element of A is an element of the set B? And that answer is yes. So A is both a set and it's contained in B. So this answer is going to be true. A is a subset of B. Last one of these, is A a subset of B, given A is the set containing 2, 7. So 1, is A a set? That's true because it's in set of brackets. 2 is A contained in B. Well, A has the number 7 and B doesn't have the number 7. So I'm going to say that's not true. So the answer to this question is false because both of these rules weren't satisfied. And for my Y, A is not contained in B. All right, so I think we're right about halfway done with the review right now. The review had 38 questions, and I've done about 19 or 20. I guess I've done actually 20 of them, so maybe we're over halfway. 19 through 21, figure out which ones of these are true. Well, first one, is A equal to B? They're not equal because A doesn't have the number 3 and B does have the number 3, so they're not equal. And when I look at this, A is contained in B. So A is a set, and A is contained in B. That makes this symbol true. So I'm done with that. And for this symbol, the same first two tests are applicable, and the third test is A is not equal to B. So if A is a set, it's contained but not equal, this is also true. So those two symbols are true. This one has a level of test that I just verified, and if the first two levels hold and A isn't equal to B, then A is also a proper subset of B. If I look at these two containments, B is a proper subset of A, or B is a subset of A, these are both false because B is not contained in A, because B has the number 3 in it that A doesn't. So the only ones that are true in problem 19 are those. So that's going to be my answer. And you don't, on your answer blank, even need to write any justification. I'm just scribbling down some justification just in case you need it. For number 20, A is given in set builder notation. I need to figure out what it is in roster form. So A is a set of natural numbers less than 3 but not including the 3. So the natural numbers less than 3 are 1, 2, and 3, but because I don't have the or equal to, I'm not including the 3. So the A is the set 1 and 2. So A is definitely equal to B because they're exactly equal. So in my answer, I'm going to include the numbers 1 and 2. And if I do this check right here, is A a subset of B? First of all, A has to be a set. Which it is. Secondly, A has to be contained. And it's contained in B because A has a 1 in it, B has a 1 in it, A has a 2 in it, B has a 2 in it. Everything in A is in B. So that's also true. Horrible answer here. The answer is not 1, 2. The answer is A equals B is true because they're equal. A is a subset of B because it's a subset. This one is not going to be true because this one doesn't allow them to be equal. So A is not a proper subset of B. For the B ones, B is a subset of A. For this to be true, B needs to be a set, and it is. And B has to be contained in A, and it's contained because they're equal. Because the two things in B, the 1 in B is in A, the 2 in B is in A, so that's true. So B is going to be a subset of A, but B is not a proper subset of A because it's that requires them not to be equal. So I don't need to write anything down but the answers. But when I do the review, I need to probably tell you my justification. But I can do these problems. When I write my key, I'll just write the answer down. I won't write any of the justification. So I believe that you can figure out the answer without, just doing it in your head. There's no need to write down what I wrote down. So the three things that are true: A is equal to B, A is a subset of B, B is a subset of A. The only time I'd write none of these are if none of the five were true. The ones I couldn't include in my answer were these, because these don't allow the sets to be equal. 21, last one of this kind. So figure out what set A is. So A is the natural numbers less than 4. Those are the natural numbers less than 4. A doesn't include the 4 because I don't have the or equal to. So A in roster form is the set that contains 1, 2, and 3. They're definitely not equal, because to be equal they have to have the same elements. Here, A is not contained in B because A has the numbers 1 and 2 in it, and B doesn't have a 1 and 2 in it. B isn't contained in A because B has a 4, 5, and 6 in it, and A doesn't have a 4, 5, and 6 in it. So they're not contained in each other. And then for subsets, one of the things that has to be true is they have to be contained. A is not a proper subset of B because A is not contained in B. B is not a proper subset of A because B is not contained in A. That's how I would do the problem if I was working on the test. Just go one rule at a time. They're not equal. They don't have exactly the same element. Is A a subset of B? No, A is not a subset of B because there's elements in A that aren't in B. Is B a subset of A? No, B is not a subset of A because B has elements in it that aren't in A. Is A a proper subset of B? Well, to be a proper subset, you need to be contained, and A is not contained in B. Is B a proper subset of A? No, B is not a proper subset of A, because for B to be a proper subset of A, it has to be a subset, or be contained. So the answer to question 21 is none of these are true. Find the following. A complement. A complement, or A prime, is all the elements in the universal set that aren't in A. So if I look at the universal set for this problem that has the numbers 1, 2, 3, 4, and 5, and I compare that to set A, which is the numbers 1, 2, 3, and 4, the complement of A would be what I get when I scratch A out from the universal set. So if I take A, 1, 2, and 3, and 4, and remove it from the universal set, I'm left with A complement. And so A complement just has the numbers 5 in it. A complement intersection B. Well, A complement we just figured out to be the set that contains just the number 5. And B is given as the set that contains the numbers 4 and 5. And when you intersect, you find what the sets have in common. So the intersection between those two sets of what they have in common is the number 5. So for my answer, it's nice if I write the problem next to my answer, but if you just write what the intersection is, it's also okay. So this would be the best answer. But if you just wrote the set that had 5 in it and didn't write the A complement intersection B, that would be fine as well. 24 wants me to do A complement union B. A complement, again, we figured out in problem 22, is just the set that contains the number 5. Then I'm going to write my union symbol, and then B has the numbers 4 and 5. And A complement union B would be the set that you form by joining the two sets together. So I put the 5 and then the 4, 5 together in one big set. And now I'm going to delete any duplication. There's 2 5s written. I don't need to write both 5s. I only need to write one of them. And I need to be nice if I write the number in a nice order. So for an answer to this, A complement union B is the set that contains the numbers 4 and 5. And again, if you write just the answer, that's fine. If you write the problem with the answer, that's fine too. Alright, so the monstery problems with the 3 sets. So 25 I need to do inside the parentheses first. So I'm going to worry about the S union second. So inside the parentheses I'm doing T, which is A, C, and D, intersecting V, which is A, C, and E. And what those have in common, because this is an intersection, are A and C. Once I've figured out what the parentheses equals to in terms of a set, I can drop the parentheses. So the T intersection V part becomes the set AC. And now I want to union that with S. Well, S is the set that has A and B. If I union that with the set that has A and C, I form a big set that has A, B, A, and C, because when I union, I just take the two sets and throw them into a big set, and then I get rid of any duplication. I don't need to write two A's, one A is sufficient, and then I write the numbers in a nice order. And again, in my answer, I prefer writing the problem next to my answer, but I'm probably not even consistent. I probably, less than 50% of the time, do I write the problem with my answer. And honestly, if you looked at my key to this test, when I write the test key, it probably will just have the A, B, and C. That would be the answer if this was the question. '26, I need to do the inside of the parentheses first. First thing inside the parentheses is V, which has, parentheses, squiggly bracket, A, C, and E for the V, and then an intersection, and then T prime. T prime I get by taking and removing the A, the C, and the D from the U set, and that's going to be B and E. So inside the parentheses, I should say S intersection, and then I'm going to drop the parentheses when I write the union down, intersection down, and what the two sets have in common, because intersection is what they have in common, is just the letter E. So I started off inside the parentheses, I wrote down what set V was, I kept my intersection symbol, I wrote what set T complement was, or T prime, and now I'm going to drop the parentheses when I condense these two sets to one set, comes out to the set E, and now I'm going to replace S with what is equals to, which is A and B, and I'm asked to find out what these two sets have in common. Well, I don't have anything in common, so my answer is an empty set, because when I'm trying to find the intersection of two sets that have nothing in common, then there's nothing that goes in my answer. So I can write the empty set, just the set bracket with nothing inside of it, or I can write the empty set symbol. 27 is a little bit harder because of the parentheses. So let me, the prime outside the parentheses, or the complement outside the parentheses. So inside the parentheses I have a V, which is A, C, and E, an intersection symbol, and then a T, which is A, C, and D. I'm not going to drop the parentheses once I get these down to a single set, because there's that complement outside this parentheses. So what those two sets inside the parentheses, because I'm intersecting them, have in common are the letters A and C. So the inside of the parentheses comes out to the set that contains A and C. I'm not dropping the parentheses yet because of the complement outside the parentheses. So I need to find the complement of that set. I find the complement of that set by removing the A and the C from the universal set. And when I remove the A and the C from the universal set, I'm left with the complement of that set, which is B, D, and E. And now I can drop the parentheses because I've taken the complement of V intersection T. So done with the parentheses, got that down to a single set. Now I want to worry about unioning this with S. So I'm going to take the result of the parentheses, B, D, and E, union it with S, which is a set A and B. And when I union two sets, I take the two sets and write them together in a big set. So I took the B, D, E, and the A and B and wrote them together. And I'm going to get rid of the duplication. Here there's two B's. I don't need to write two B's. Those four letters, B, D, E, and A, need to be in my answer. So my answer is going to be V intersection T prime union S equals, and I'm going to write those alphabetically. So I'm going to write A, B, D, and E. Cool. So So it's A, B, D, and E in case it's, let me just try to write that again. It says A, B, D, and E. Okay, sketching. Intersection, we need to do the graphs. Well, I need to do the graphs in different color. So the first thing I'm going to do is I'm going to graph A in pink. And A represents anything inside the A circle. Secondly, I'm going to do B prime, maybe in this green. B prime is anything, well, it's supposed to be inside the rectangle, so I'm technically not supposed to be shading outside the rectangle, but it is what it is. So B prime is everything that's outside the A circle. I look at the two shadings, and an intersection, I need to get where the shadings overlap. And so that's where I have both pink and green shading. So my answer to 28 is going to be that region. Highlighters, I think, do the best shading for this. Markers kind of cover up what you need to. Pencil's kind of a nuisance to shade with. 29, I only left myself one blank because I only need one blank. Unions I can do all in one color. First I'm going to shade A prime. A prime is everything outside the A circle. The best I can, I'm shading outside the A circle. It's really not the best, art is not definitely a skill of mine. So that's A prime. Well, more or less, A prime is everything outside the A circle. And when I do union, I'm just going to now shade inside the B circle in pink. And I'm not worried about overlapping. Anything that's shaded is part of my answer. So that would be the whole answer for number 29. That's A prime union B. Done in one quickly nice step. Unions I can do with one graph in one color because anything that's shaded in either of the sets is going to be part of my union. 30. First I'm going to do A intersection B. And to do A intersection B, I'm going to graph the A in pink and the blue B in green. And the intersection is where they have in common. So A intersection B is going to be this region. So in lovely blue. And now I'm going to intersect that with C prime. So I could do it right on this graph in a new color. I'm going to intersect with C prime. And I'll do the C prime in pink because I have it here. And C prime is anything that's outside the C circle. So I want the overlapping between these two shadings because it's an intersection. That's why I did it in two colors. And that's this region here. So my answer to problem 30 is going to be that region up here. When we go to do the next group of problems, I'm going to use a lot of the shadings that I just did. So I'm going to keep my answer handy for 28, my answer handy for 29, my answer handy for 30. I'm going to keep all these answers just real at my fingertips because I'm going to need them. Oh, it'll make my work quicker for the last few problems. So first in 31, I'm working left to right. There's no parentheses. I'm going to do B union C. I could do that in one color. So B union C, first I shade in the B circle for the B part of the B union C, and then I do the C circle for the C part of B union C. Now, right on this graph, I'm going to intersect it with A prime. Intersection I do in a different color, and I'm going to do it in blue. And A prime is anything outside the A circle. And then for an answer, it's anything that's shaded two colors because I want to intersect this set with that set, and when you intersect those, you get multiple colors. And where the multiple colors is, I'll put all the different colors. it's going to be this region. So this is the final answer to number 31, because it's where the B union C shading intersects with the A prime shading. I almost think I don't need this one in my next group of problems, but I'll keep it handy just in case I do. 32, I have to do the inside the parentheses first. So the first thing I'm going to do is B union C, which is B union C. So that's the B union C part. And now I want to intersect that with A. So in a different color, I'm going to draw A on this. And when I need intersections, I need where both shadings exist. For my answer, I want where the two shadings, where I have both color shadings, because intersection you need overlapping, and that's going to be this region there. Now, attaching numbers to the sets and finding out intersections and unions. This is what I'm going to pull on my work extensively. So first part of doing problem 33 is to make a shaded region for A intersection B prime, which we did in 28. So 28 asked me to shade intersection B prime, which I got that for an answer. I'm going to apply that shading to this picture. So this is the shading that I got when I shaded A intersection B prime. The answer to problem 33 are just any numbers or any elements inside the shaded region. And hopefully you can still read those. That's the numbers 1, 3, and 5. Let me blow it up a little bit. I don't know if it's going to make it any more readable. But 1, 3, and 5 are in the shaded region. So on the test, I think I'm that nice where the problems that have you shade, I get reused, so you don't have to shade again. 34, I need the shading for A prime union B. And fortunately, I have the shading for A prime union B. So I'll apply my shading for A prime union B to the diagram that's given. Don't really even need to apply it, but I'm going to apply it just in case you need to see it. I mean, you just need to be able to visualize, in putting the shading to this graph. So I've put the shading to the graph, more or less. Any number that's in colored up is going to be part of my answer. So 1's not going to be part of my answer, nor is 3, but 2 will be part of my answer. 3 won't be part of my answer. 4 will. 5 won't be part of my answer. 6 will. 7 will. 8 will. 9 will. And 10 will. So my answer to 34 is 2, 4, 6, 7, 8, 9, and 10. This was the problem that was a mess up on my part. If you look back at the problems that we did, here's A intersection B intersection C prime, that says union, so that one's not the same. B union C, that's not the same as that. And this wasn't the same as that. This is a shading we hadn't done yet, unfortunately. I need to do this shading, so let me add this shading to here. So first, to shade this, first I'm going to do A intersection B. My A circle, my B circle, my C circle, and then I'll do the A in pink, the blue for B, intersections where you get the overlapping, so A intersection B part of this. Do it in blue because I just picked it up. That's the A intersection B part. And now I want to union that with C, so I don't need a new color for union. One color is enough. And I'm going to union that with C prime. And C prime is going to be anything outside the C circle. So I'm going to go outside the C circle. Running out of highlighter. So that would be A intersection B, which is that region, union with C prime. I'm going to apply this to the graph. So I get this whole middle region, and then anything outside the C circle. And then any number that's shaded up is going to count. So if I go one at a time, 1 is not in a shaded region, so it's not going to be part of my answer. This is 2 here, it will be part of my answer because it's shaded. 3 is in a shaded region, it needs to be part of my answer. Both 4 and 5 are in shaded regions, they're going to be part of my answer. 6 won't be part of my answer, 7 won't be part of my answer, 8 will be part of my answer, 9 will be part of my answer, and 10 won't be part of my answer. So my answer to 35 that I wasn't so kind to give you the shading, had to figure out the shading, should be 2, 3, 4, 5, 8, and 9. 36, I actually have the shading for that, I think. I thought I did. Yeah. The shading for 36 is that. I wonder if did I put it all in there? Yeah, it's all in there. So the shading, the answer to the shading for B union C, oh, it is not the same. Really? I almost think maybe I had, maybe I did more work there than I needed to. Maybe I was being stupid, but it's because I'm getting fatigued, I guess. So for 36, which is the last problem, thank gosh, I'm going to do all in one color because of all unions. First I'm going to do B union C. So B union C is that region. And then I'm going to union it with A prime. So to that, I'm going to shade outside the A circle. And unions I can do all in one color. That's going to be B union C union A prime. And so basically I'm shading everything. If I apply this shading, it's going to shade every number except that 3. I guess I was really not wanting to shade this, but it's going to take 2 seconds to shade it horribly, so I'll do that. So that's B union C union A prime. And every number between 1 and 10 is covered up other than the 3. So for my answer, I'm going to write every number between 1 and 10 other than the 3. So 1, 2, 4, 5, 6, 7, 8, 9, and 10. So that's everything on the review. If you can do all the problems on the review, I'd be perfectly fine for the test. If you take the time to do the homework and show me your homework, you're allowed to use a note card when you take the test, and that gives you a huge advantage. So remember, you need to show me the note card. And I mean, usually I teach Math 142 on Tuesdays, so it would, no, on Mondays now. So it would be like by email by Sunday at 5, or in person. I'm always on campus on Thursdays, not always on Fridays. So whenever my office hour is on Thursday, or Friday if I have office hours, show it to me in person or email me the homework so you can use a note card. All right, thank you so much.